Hello friends, subscribers and new viewers of this channel. In this large language model and machine learning tutorial, we explain how to run Llama 3.2 1 billion and 3 billion parameter models on Raspberry Pi in Linux Ubuntu. In this tutorial, we use Raspberry Pi 4. However, the performance and the speed of running the models will be better on Raspberry Pi 5. Almost everything explained in this tutorial applies to Raspberry Pi 5. The only difference is that the process of overclocking the processor will be different since you need to use different settings and parameters that are more suitable for Raspberry Pi 5. Over here you can see a demonstration of Llama 3.2 1 billion parameter model. I'm executing model by using the Ollama framework. Then, once I'm inside of the model prompt, I'm asking a question, how to solve a quadratic equation. And you can see the answer. Here it is. The answer is perfect. Now, to generate this answer, it took maybe 1 minute on my Raspberry Pi. And this answer is being generated line by line. Consequently, you might even attach some model that will transform text to voice, and it's going to look like the answer is being generated in real time. That is, it's going to be generated by a person who looks like speaking to you. And this is just one of the ideas of using this framework. Of course, if you're running Raspberry Pi 5, which I will do in my next video tutorial, the execution might be significantly faster, maybe even 2 or 3 times faster. However, I have to investigate that. But before we start with explanations, we need to emphasize this. First of all, in this tutorial, we will be using Raspberry Pi 4 with 4 GB of RAM. To enhance the performance of Raspberry Pi 4, we will be overclocking its GPU and CPU. Furthermore, we will increase the swap memory file size in order to be able to run 3 billion parameter model. This is very important, otherwise we will not be able to run 3 billion parameter model since it cannot fit in 4 GB. On the other hand, if you're using Raspberry Pi 4 with 8 GB RAM, this might not be necessary. However, we suggest to everyone to increase the swap memory size. This will increase the stability and make sure that the applications do not stop due to the lack of RAM memory. On the other hand, if you're using Raspberry Pi 5, you can also try to increase the swap memory. Here is the disclaimer regarding overclocking and swap memory adjustments. We don't take any responsibility if after overclocking the system becomes unstable or crashes. In our case, the system remains stable after overclocking. We have a heatsink and a cooling fan attached to our Raspberry Pi that keeps the temperature constant. However, it might happen that if Raspberry Pi is not properly cooled, the overclocking process might overheat the processor and create irreparable damage. We don't take any responsibility for this, or if your system crashes after overclocking. The crash of the system can be easily repaired by reverting the settings. However, if your CPU or GPU overheats, then the damage is permanent. Also, we don't take any responsibility if after changing the swap file size, the system becomes unstable. Then, in this tutorial, we are using Linux Ubuntu 24.04. However, you can also use any other supported version of Linux Ubuntu. We created a separate video tutorial explaining how to install Linux Ubuntu 24.04 on Raspberry Pi. A link to that tutorial is given over here, and it will be also provided in the description below this video. Then, instead of using a micro SD card to run Linux Ubuntu, which are known to be very slow, we are using an external solid-state drive or SSD. The SSD drive is connected by using a USB 3.0 port to a Raspberry Pi, and we installed Linux Ubuntu on this SSD. Here's our SSD. Let me now scroll down to show you. This is Raspberry Pi, and here's my SSD. It's a Buffalo SSD with a capacity of 1000 GB. And here's a disclaimer, I'm not being paid by this company or any other company to promote their products, just to make clear. Now, by installing Linux Ubuntu on this SSD, we can 10 times increase the read and write speed compared to micro SD card shown over here. Consequently, if you have money and if you want to invest in your hardware, purchase a solid state drive. You don't need to buy 1 terabyte solid state drive, as in my case you can buy a smaller one, and the speed will be probably even 10 times or 5 to 10 times faster compared to SSD card. You can also purchase an external SSD from SanDisk. I tested both of them and they work really good. Then, since we are using a program to record our voice and screen, it might happen at a certain point that our recording glitches due to the fact that CPU capacity is maxed out by the recording software and by running Llama 3.2. Consequently, excuse me for that. Also, in the background you might hear a fan. That's the fan from Raspberry Pi. I'm running fan at the maximum speed in order to be able to cool Raspberry Pi while running Llama 3.2. Okay, let's start with explanations. In the first step, we will overclock our GPU and CPU and we will increase the swap file size. In the first iteration, you might consider to skip the overclocking step. Also, if you're using Raspberry Pi 5, you can either skip this step or use the correct overclocking parameters, and you can search online for them. Here are some important notes to keep in mind when overclocking. First of all, the standard CPU frequency of Raspberry Pi 4 is 1500 MHz. Online, it is reported that Raspberry Pi 4 remains stable up to 2000 MHz, and instabilities have reported above this frequency. In our case, we will use a frequency of 1800 MHz just to be on the safe side. The standard GPU frequency is 500 MHz. We have noticed that it's okay to push this to 750 MHz. Before you overclock, you have to make sure that you have a fan attached to the Raspberry Pi 4 and that heat sinks are attached to the CPU and GPU. Also, make sure that you have a proper power supply that is rated for at least 3.5 amps. Okay, first of all, to overclock, you need to open a terminal and you need to execute this command. Now, you can see that what I'm doing is quite slow. For example, pasting or copying. This is mainly due to the fact that I'm recording this video using a software, and consequently, the recording software is using a lot of GPU power. However, in your case, everything will be quick. Okay, so let's execute this command. Here, you need to enter the password. To overclock our Raspberry Pi, we need to edit this configuration file. To do that, we will use the Nano Editor. Nano Editor is super simple and I like it a lot. It's much more simpler to use than Vim or VM or any other similar Linux-based or Unix-based editor. Okay, so let's see what has to be edited. Scroll all the way down, and over here you need to add these 3 lines. The first line will increase the voltage value or level to 5. Note that these are not volts. We are just increasing this value that probably scales from 1 to 10 or something similar. However, don't experiment with this voltage parameter, leave it as 5. Then over here, we increase the CPU frequency to 1800. You can even try to push this a little bit further and see if instabilities occur, then reduce it down to 1800 MHz. And over here, we increase the GPU frequency to 750 MHz. Okay, let's save this file. To save this file, you can either press Ctrl S or you can press Ctrl O and press enter, and after that press Ctrl X to exit, and that's it. Now, you need to restart the computer for these changes to take effect. However, before we restart the computer, we need to increase the swap file size. Okay, loosely speaking, and this is not 100 correct statement, swap memory will virtually increase RAM size. On the other hand, it will occupy some extra space on your SD card or an SSD. It's not suggested to use an SD card when increasing the swap file size, since the swap file size requires a lot of read and write, and SD cards don't like that. Consequently, use an SSD. The swap memory will be used in addition to the regular RAM memory, and especially when the RAM memory is totally consumed. That is, the applications can store their data and processes in the swap memory. By increasing the swap memory, we can improve the stability and prevent some applications from crashing. To increase the swap file size, we need to perform these steps. First of all, let's type this. I think it's faster if I type. Let me see. Sudo, yes, good. Swap on show. This will show the swap file size, and in my case it's 10 gigabyte. Okay, this is not bad actually. Usually once you install Linux Ubuntu and Raspberry Pi 4 or 5, I think the swap file size will be around 1 gigabyte or maybe even 2 gigabyte, depends on the model. Now, before we make any changes, we need to disable the swap memory. To do that, type this sudo and then say swap off with the parameter A. And now again, look here. This looks like it's executing slowly, but it's not. This is mainly due to the fact that I'm recording this video. Okay, let's wait a while. Let me now stop recording and then. Next, we need to erase the current swap file size. Let's do it. To do that, you need to type this sudo rm, and the swap file is called swap file, just like that, and it's located in the root folder, and just erase it. Now let's increase the swap file size to, for example, 15 gigabyte. Over here it's written 10, and this is my old setting, and I'm going to increase it to 15. So I will type sudo full locate or full locate, and then let's use this option L. I will increase to 15G, and what you want to do, you want to increase swap file, and that's it. Okay, next we need to set the permissions such that only the root user, that is only the person running sudo, can actually change and manipulate this file. Consequently, let's set the permissions by using chmod, and to implement these changes we need to type this. And let's see what happens here. Okay, you can see now setting up swap space version 1, size is now 15 gigabyte. Looks good, okay? Finally, we need to enable back the swap memory in a swap file. We can do it like this. We will just call sudo swap on and the name of the swap file, and basically that's it. Okay, this looks good. Now, we need to restart the computer and the overclocking and swap file changes will be implemented. Let's do that. After restarting the computer, let's verify that the file size is correct. To do that, we need to execute this sudo swap on, and let's see show. And you can see the swap file size, it's increased to 15 gigabyte. Another approach for checking the swap file size is to open a new terminal, and over here you can type top. And you can see the swap file size, it's around 15 gigabyte, and you can see the standard memory. And another important thing that you can observe is the CPU usage. You can see that Kazam is using 161% of my CPU. That is, the recording software is using most of my CPU. Okay, the next step is to install Ollama and Llama 3.2 1 billion and 3 billion parameter models. The first step that you need to perform is to make sure that your computer allows for inbound connections on this port 11434. This port is used to check and validate Ollama. Consequently, go back to this terminal and you need to execute this command to allow for connections. Again, this is a local port. You're not opening anything to external world. And okay. Next, I need to explain several things. We are going to run Llama 3.2, 1 billion and 3 billion parameter models by using Ollama framework. Ollama framework is an interface for running a number of different large language models. And consequently, if you're completely new to large language models and Llama 3.2, my suggestion is to use Ollama. That's why I'm creating this tutorial that's based on Ollama. Of course, there are several other approaches for running large language models. You can run them in Python, and I made a number of tutorials explaining how to do that. You can check my YouTube page. And in the future I will create more tutorials. To install Ollama, we need to execute this command. This command will actually download and execute this script, install.sh, and this will install Ollama on your computer. So let's run this. Over here you can see the download progress. It's going to take a while to download everything, maybe even several minutes. However, you should be patient and wait for the download to be completed. And after several minutes you will see this message. The Ollama API is now available at this port. This is basically our local host and this is the port. And then install complete. Run Ollama from the command line. Warning, no NVIDIA AMD GPU detected. Ollama will run in CPU only mode. And this is expected since Raspberry Pi only has a CPU, it also has a GPU, however the GPU is not powerful and it cannot be run to execute machine learning models. Maybe it can, however I'm not aware of that. Okay, before we can do anything with Ollama, we have to make sure that Ollama is running in the background. To do that you need to type Ollama serve. And this will run Ollama in the background and we can start using it. Consequently, open a new terminal, and over here in this terminal we have two models, the parameter model and the parameter model. Actually, the 1 billion we need to execute the model Llama 3.2 repository. So let's execute, and over here you need to be patient. After some time you will see this message pooling, and you can see you need to download our 0.3 gig. You need to be very patient. And then after several minutes you will see these messages, and this means that the model is downloaded. Let's verify that the model actually exists. You can type Ollama list and you should see the model. Here it is. Perfect. The next step is to download 3 billion parameter model. Consequently, we need to execute this command. Here it is. Now, again, we have to wait. You can see that the model is around 2 GB, and let's wait. And after some time, you will see this, and again, type this, Ollama list to list everything, and here's our second model. The first model and the second model, and next let's learn how to run these models. We can run the models by using a single line. Let's run 1 billion parameter model. Type Ollama run, and over here copy and paste the name of the model. Here's the name of the model, and let's just paste it here. and bang, we can run the model. Now, it's going to take some time to load the model, so be patient. And then after some time you will see the model prompt, that is the Ollama prompt that will send the messages to Llama 3.2, and let's ask a question: how to solve a quadratic equation. And let's see the response. Now, again, it's going to take some time to compute the response. And over here you can see how the model is being generated in real time. It is actually much faster. My recording slows down the model and then just convert. And then after a minute or so, the answer will be generated. And here it is. Looks very good. By using the same approach, you can run the second model. You just need to specify the name of the model. To exit the prompt, you need to type by, and then again, let's type Ollama list to list the model. And to run the second model, you just need to copy the name of the model, and then you need to type Ollama run and the name of the model, and you can execute the model. We have noticed that this model is significantly actually slower compared to the first model, and this is mainly due to its size, and is going to use the virtual memory. However, if you're having, for example, a Raspberry Pi 4 with 8 GB of RAM, or Raspberry Pi 5 with 8 GB of RAM, this should be quicker. The execution should be quicker. Okay, that's all for today. I hope that you liked this video. If you like the videos I'm creating, please press the like and subscribe buttons. Thanks a lot and have a nice day.